Today we're learning about one of the most important computer science principles, abstraction. Abstraction means hiding details so we can focus on the bigger idea. In Python, we use abstraction every time we group details into a function, a class, or even when we use built-in libraries. Think about driving a car. You don't need to know how the engine burns fuel. You just use the steering wheel, pedals, and dashboard. The complex details are hidden. That's abstraction. There are many types of abstractions. For example, functional abstraction, functions that hide a sequence of steps. ADT exposes operations without exposing representation. Object abstraction, classes that bundle state and behavior. Module, package, and library abstractions, groups many things behind a public API. Control abstraction, constructs like loops, generators, and context managers that hide control flow details, and many more. Here are some examples of abstraction. The first line directly calculates the circle's area using the formula pi r squared, but if you need the calculation in multiple places, you'll end up duplicating the code. In the second version, we abstract the logic into a function, area of circle, radius. Callers don't care about the formula inside, they only see a simple reusable interface. This shows the easier reuse, readability, and maintenance. If the formula changes, maybe use math.py. You can change it in one place. Internally, we use Python list self.items to store elements, but the user of stack doesn't interact with the list. They use methods push pop is empty. This hides how the stack is implemented. If we later switch to dequeue, users wouldn't notice. This is an abstract data type, ADT. Users focus on what the operations do, not how they're done. A database object abstracts away details of opening and managing a connection. The user just calls dbQuery select. They don't see sockets, buffers, or authentication. The benefits of this are cleaner interface and easier to swap implementations without changing user code. Here, enter and procedural make db usable in with the block. When entering, it opens the connection. When exiting, it closes automatically, even if an error occurs. The with statement abstracts away the lifecycle management. The benefit of this is it prevents resource leaks, simplifies code, and reduces mistakes, forgetting to close connections. When you decorate compute with add timeit, the timing logic is automatically applied. Users just call compute and it prints how long it took. Yield turns the function into a generator. Instead of loading the entire file into memory, it abstracts the iteration to give one line at a time. The caller doesn't care how lines are read, they just loop. Path objects abstract away differences between Windows and Linux. Instead of manually joining strings and use methods like .exists and read text. Internally, decoding, filtering, and encoding are complex. Externally, the user just calls process in, out. When you design an abstraction, test at the right level. Unit tests should cover the contract, not the hidden details. Use mocks for internals so tests don't break when you refactor. Then use integration tests to ensure the real implementation works end to end. Finally, if your abstraction is public, use semantic versioning. Avoid breaking changes. If you must, document them and give users a clear migration path. Abstraction is powerful, but don't overdo it. Avoid premature abstraction. Don't build a general layer unless you see multiple real use cases. Remember YAGNI, you aren't gonna need it. Don't create overgeneralized abstractions that try to solve every problem. They become confusing and brittle. And be aware of leaky abstractions. If your interface hides something users must know, it will cause frustration. To wrap up, abstractions mean hide how, expose what. In Python, we do this with functions, classes, modules, context managers, and decorators. Good abstractions are small, clear, and stable. Avoid premature or leaky abstractions, and always test the boundaries and provide clear documentation. That's how you design abstractions that last. Thank you very much.